Alright, I wanted to revisit parity so people would have some more notes on this. So here's the idea of parity. Permutations, remember, permutations are just rearrangements of things. As far as our puzzles go, whenever we do some series of twists on the cube, we're doing a permutation. We're moving pieces around. These permutations fall into two categories, odd and even. And what the odd and even are referring to is the number of equivalent swaps. And we'll talk about that. Number of equivalent swaps. So here's one simple example. A 2-cycle has odd parity because a 2-cycle is one swap. That's exactly what it is. Now, we don't see a single swap on the Rubik's Cube, but here's an example on a 4x4. Notice that everything is fine except these two corners. They need to be swapped. They're in the wrong place. So this sort of thing looks like up, front, left, up, front, right, and back again. This is an odd permutation. It can also occur on the 2x2. I mentioned this before in class, that this is you can end up with something like this, where these two corners have to be swapped. This doesn't show up on the 3x3. Now, certainly some permutations would be pretty easy to figure out this way. If you have a pair of 2 cycles, that's even. It's literally 2 swaps. Every 2-cycle is a swap. So you could have 2 of these things. An example would be something like this. If you look at what's happening here, these, let's see, I read, yeah, so these 2 corners are swapped, and then these 2 corners are swapped. So it's certainly okay to have something like up, front, right, up, front, left, and back, as long as you also have something like up, back, right, up, back, left. So it's okay to have a pair of these. That happens on the 3x3s. So that's okay. Now what about all the other ones? Our permutations usually have more complicated cycle structures. So what about, I'm going to move this paper for a moment. What about a 3-cycle? Now, we have experience with 3 cycles, and when you solve the cube, your last step involves a 3-cycle. You're just moving 3 edges. So what I just did on my 3x3x3 involved this 3-cycle, moving 3 pieces, and that was it. So is a 3-cycle odd or even? And the way we figure this out is it equivalent to an odd or even number of swaps? Now what's tricky about this is that we don't actually do physical swaps when we solve the cube. At no point are we trying to pry pieces out and trade them. Now one way you could think about this is, well, so I have this permutation, and I did it by doing a bunch of twists. How many swaps would it take to get the same thing starting from a solved cube? Say something like this. How would I do that? Well, you can imagine swapping these two. So if I swapped Let's see if I can do this. If I swapped these two, that would put the red here, and that it would put the yellow right here. And then I swapped the yellow for the orange. That would accomplish it. I could imagine doing it in 2 swaps. Let me show you what I mean by that. So imagine that I had, say, 3 letters, A, B, C, kind of arranged as a triangle. And imagine that I have a permutation of those 3 letters. So something like A, B, C. So this is a permutation. You can imagine, right? A goes to the B spot, B goes, wait a minute, A, B, C, clockwise, A, B. Yeah, A goes to B, B goes to C, and C goes to A. Yep. So this is a 3 cycle. They're moving counterclockwise, just like the edges on the cube that I showed you. Now, how many swaps would it take to do the same thing? So imagine if I swapped A and B, so I'd get something like B, A, and C. And then from here, if I swapped B with C. So the idea being, if I swap these 2 letters, I end up with this picture. And if I swap these 2 letters, I end up with this picture. 2 swaps would be the same as this 3 cycle. 2 swaps would equal the 3 cycle. And there's no way of doing it in 3 swaps or 1 swap or 5 swaps. It would always be an even number of swaps. And so this little diagram, if you will, this little sort of argument is to sort of make it believable that a 3 cycle would be 2 swaps. 2 is an even number, so then a 3 cycle would be even. Would have even parity. Now, if a 2 cycle is odd and a 3 cycle is even, it seems believable that a 4 cycle would be odd. But I do want to show you, I'll do one last example. So let's start with a 4 cycle. I don't have one of those off the top of my head, but on the cube this would amount to something like one corner going here, and this corner going over here, and this corner going over here, and this corner going over here. So I could make one up, but we don't really need to. Let's think about this as a square. Let's imagine that we have, say, 4 letters A, B, C, D, and that we take a 4 cycle, a permutation of those, which looks like A, B, C, and D. So this is a 4 cycle. A went to B, B went to C, C went to D, D went to A. So just you could use cycle notation if you wanted to. But let's see how many swaps it would take to accomplish this. I'm going to swap A and B, and then that would give me this. And then I'm going to swap, let's see, I'll do B and D. This isn't the only way you could do this, but I suggest trying it. You won't be able to do it, and you can do it more than me, but it'll still be odd. And then the last swap that I need to do would be B and C. So I start, if I swap these 2, that's what's changed. If I swap these 2, that's what's changed. If I swap these 2, now I'm to the original 4 cycle. So that was 3 swaps, and that's odd. So the idea is that 2 cycles and 4 cycles are odd, 3 cycles are even, and in fact so are 5 cycles are even. In fact, and this is a little confusing, an odd cycle is even, and an even cycle is odd. So what do we do with this? Well, suppose we have, let's go look at a permutation. We'll look at a simple one first. Let's look at, say, f. I just did f. Well, f moves 4 corners and 4 edges. You may want to verify that up front left goes to up front right, goes to down front right, goes to down front left, and back again. And that the up front edge goes to the front right edge, goes to the down front edge, goes to the front left edge, and back again. So that's a 4 cycle, and this is a 4 cycle. So this is equivalent to 3 swaps. This is equivalent to 3 swaps. Even though it's not a literal 3 swaps, you could achieve the same thing if you physically remove the pieces 2 at a time and swap them. So this is the same thing as 6 swaps, which is even. So f is even. Now the important thing here is to note that that was f, but it's no different for r. R still has 4 corners that will be in a 4 cycle and 4 edges that will be in a 4 cycle. U would still have 4 corners in a 4 cycle and 4 edges in a 4 cycle. It wouldn't matter if I had done fi. That's still 4 corners in a 4 cycle and 4 edges in a 4 cycle. So every quarter turn of a face of a 3x3 is an even permutation. Every quarter turn of a face of a 3x3x3 is an even permutation. So what we can do with that is the following. Now if I were to take something like fr, well, f represents an even permutation. R is an even permutation. What does that mean? Number of swaps. Number of swaps. F is equivalent to an even number of swaps. R is equivalent to an even number of swaps. Any even number plus any even number is even. So FR is even. And you might even remember that we had a 7 cycle on, we did this one in class, edges, and we had a 5 cycle on corners. There was a tricky 3 cycle we're not going to look at because it only dealt with orientation. We're actually not dealing with orientation here. We're just dealing with where things go. And it's a separate parity issue with orientations. So a 7 cycle, that's the equivalent of 6 swaps. This is the equivalent of 4 swaps. This is the equivalent of 10 swaps. Is even. So there's a couple ways of thinking about this. So the punchline, and it doesn't matter if you do FR, you could do F, R, U, L, F, I, R, I. Every one of these is even. It's even plus even plus even plus even plus even plus even is still an even permutation. So what does that mean for the cube? Well, it means that you can't have things like this on the 3x3. What's this? Well, that is UFL equals UFR and back again. That's a 2 cycle all by itself. Nothing else is affected. It's the same here for this 4x4. There's a 2 cycle on the corners and nothing else is affected. That's odd and impossible on a 3x3x3.